Record one last quick video, a part C to this learning goal, talking about periodic trends and what we observe with these different types of unit cells. Okay, and I want to draw your attention right away to the face-centered cubic and the commonly occurring precious metals, copper, silver, gold. Pretty cool, right? They're all on top of each other, so that means they're all going to share the same periodic trends. And one of those periodic trends being their unit cell. These are all face-centered cubic, okay? And I want to describe these properties just a little bit more. So if you have any amount of familiarity with copper or silver or gold, then you'll recognize that they are quite malleable. So let's write that down, assuming I can spell. Malleable, or I definitely can't spell soft. So for example, if you are familiar with indoor plumbing, all of the plumbing in your house, your water delivery lines, are made out of copper because they're so easy to bend and still maintain the structural integrity of the metal. And the reason for that is because it's a face-centered cubic. So if I back up for a moment and look at this face-centered cubic, these different layers here amongst the unit cell, they make what's called slip planes, okay? So I'll say slip planes. And so now what you imagine, right, as we start bending a piece of copper tubing, we're going to deform the unit cells along where we're bending it. And the bend is going to happen along these slip planes. So in other words, atoms in these slip planes can slide down and bend over each other, which allows the material to be manipulated, bent into a certain shape. Also, silver and gold are commonly used to make jewelry. And that's exactly why, for one, well, because they're shiny and pretty looking, but number two, the face-centered cubic structure gives it this malleability, this ability to flex it, to bend it, and still maintain its structural integrity. And I want to compare that to something like iron, a body-centered cubic. So we don't use iron for jewelry or for bending pipes. We use iron to make buildings, right? We use iron to make these large girders or these large beams that have immense structural integrity. And the reason why there's such a difference between iron and, let's say, copper, silver, gold, and that lattice is once again because of these slip planes. So if I go back and look at the body-centered cubic, look, there's only one slip plane amongst that layer. Okay, so not only does this mean the solids, the body-centered cubic solids, are more rigid, so they don't have as many of those slip planes that can just slide right over. So that means they're more likely to snap or break instead of bend. But what that also means is they're much harder. So they're much more less likely to bend or deform. So I'll say hard. So that's why we build a building out of iron or other structural materials where we don't necessarily need it to be flexible. We need it to be strong and rigid, okay? And so, of course, we could go through all kinds of other examples, but generally what you see is this lovely periodic trend here amongst the metals. And the last one that I'll also describe, you can see titanium right here belongs to the hexagonal unit lattice. And the hexagonal is a much stronger, more rigid unit lattice than the face-centered cubic. So, right, it's all about those slip planes. So you can see the hexagonal only has that one slip plane. So that's why you also see titanium being used in structural applications.